Welcome. My name is Bob Tickelman, and I'm a Microsoft technical trainer, and I'm excited to be your guide in this AZ-500 Microsoft Azure Security Technologies. In this learning path, we're going to take a look at three specific modules where we're going to take a look at implementing security for virtual networks. We're then going to take a look at private access to Azure resources, and then looking at public access to those same Azure resources. What we want to do is, from a security perspective, is not to teach you about NSGs and application security groups and VNets and all the networking components. We want to take a look at the implementation of a security against these resources and how you can have a focus specifically from a security perspective of how to secure your network communications to the resources, whether they be in Azure or on premises. In the first module, we want to take a look at virtual networking components. When we take a look at the MCSB, or the Microsoft Cloud Security Benchmark, as a feature of Windows Defender for Cloud, there's a broad spectrum of capabilities that you can now use Windows Defender for Cloud and the MCSB categories to implement security across your networking components. Now, I'm not going to go into all of this. It's in the course content, and I'm just going to actually take you on a quick tour specifically around the aspects that we're going to be looking at in this next few minutes. Looking at the content for the course, in the first module that this slide relates to, it highlights several areas of the networking components of the Microsoft Cloud Security Benchmark features. And you can see all of the attributes that are going to be highlighted in the MCSB. If you take a look at the documentation specifically, this is just a part of the series that we're going to talk about, as well as the MCSB capabilities itself. So under network security, this is the detailed documentation if you want to get more information, more than just what the course has. But all of this information related on all these topics is going to be covered in detail there. So knowing that we have the capability of monitoring and controlling your network configurations, let's take a look at where it can be applied to these different network resources. So the first networking component we want to start with is an Azure Virtual Network. Now, networking as a fundamental concept, it has to be universal in the way it works. And so a lot of the technology and the understanding of networking that you already bring to Azure is going to be actually the same. There's going to be a few differences, mostly in names in the application that I'm going to highlight from what you might be used to. So an Azure Virtual Network is a regionally based unit of networking. And so you want to manage this on a per region basis. And you'll see that what the benchmark does, and Windows Defender for Cloud, by using the benchmark, you're going to be able to have a global standard and a way to manage all of these. But specifically from a security perspective, the VNet or virtual network that you create in a region that might be similar to what you might have called on premises as your subnet. I've got a 10.1 subnet or network that you're working with. That is equivalent to our virtual network. It is an address space that you're working with. Within inside of that address space, there's a whole bunch of security that we can implement. By default, a VNet has at least one subnet inside of it. And we often recommend that you have multiple subnets depending on your N-tier architecture. And so in a security class, if you take looking at our network design, we often talk about an N-tier architecture or three-tiered architecture where you have a front end, middle tier, and back end. Now I'm going to draw all this out in a form of a whiteboard that brings this and several other concepts together in a few minutes. So I'm just laying down the concepts so that you understand when I get to that diagram what they're all going to do. Now, by default, within a VNet, all of the subnets can talk to each other. There's nothing stopping them from communicating. And if you really want to have that N-tier architecture where you want to restrict access between your front end, middle tier, and back end, you're going to want to be able to apply some security in there. Now, by default, there is a thing called an SDR, system-defined route, that automatically communicates that all subnets in a VNet can communicate with each other. So we want to be able to take a look at being able to manage that. And so you have this concept called a UDR, user-defined route. So you can customize it to meet your routing definitions. but that's routing, that's not security. We're going to eventually get to a feature called an NSG, or Network Security Group, which is the security overlay that you'd be able to manage with the benchmark, as well as with your configuration to manage that traffic. But a VNet as a foundational network component, a regionally based unit of networking that has one or more subnets, that has an IP address range that's associated with that. We then take a look at the Azure Virtual Network Manager as a global basis. We've talked in other recordings about scope, and we've talked about the scope starting at the tenant level. And in the tenant, you then flow down in this hierarchical structure of your management groups. That's what you see at the top of the slide. We start with our tenant root management group, and you can have up to 10,000, if you remember, up to 6 levels deep of your control. We then get subscriptions as the next scope that you're dealing with. And then below that, you get the resource groups and then the resources. So they've skipped the resource groups there in just a minute, or in that diagram, but they're just showing you that hierarchical structure that from a virtual network manager perspective, you can manage globally your deployment of networking resources, and then we could then measure those and control them through Windows Defender for Cloud using the Microsoft Cloud Security Benchmark. Now, I've talked about these a few minutes ago. So the NSG and a thing called an ASG. So the Network Security Group, for all intents and purposes, is a watered down version of a firewall. So this is our first layer of security. And NSG is what they refer to as a 5-tuple hash. So there's 5 different characteristics that we can use for filtering both inbound and outbound traffic through the network security group. Now, it doesn't have all of the advanced features of firewalls, and we'll cover those in another part of the recordings. But an NSG is a free tool. So that's the first thing. It's free, and you should use this everywhere. And we often talk about, people try and stop traffic coming in, and absolutely that's where you want to block as much traffic as possible. But you also want to not just look at ingress, but you want to look at egress, the export of information. So don't forget to set up NSG rules to make sure that you're not exfiltrating information outside of the network segment that information is supposed to be retained in. So your NSGs, or network security groups, is a free tool that you can sprinkle around inside of your network topology. Now, they apply at 2 different levels. They apply at the subnet level with inside of a VNet. So we just talked about a VNet, a virtual network, has 1 or more subnets in it. I talked about having, 3 possible subnets in a VNet to separate your front end, middle tier, and back end. So as opposed to using a UDR, a user-defined route, you can now do this using the NSGs, where you can now restrict traffic into the front end, only coming from maybe, the application gateway or whatever the entry point is into your application. You then restrict using the NSG from the middle tier, or from the front end tier to talk to the middle tier. So the outbound from the front end only can talk to the middle tier. The inbound for the NSG on the middle tier can only come from the front end or the back end, so both can have inbounds to it. And then the outbound from the middle tier can go back to the front end, or it can talk to the front end, or it can talk to the back end. I just got my fingers all mixed up there. And then vice versa, you go to the back end can take requests from only the middle tier, not the front end, and it can only respond back to that middle tier. So using those NSGs are a great way to set this up. Now, I mentioned that at the subnet level. NSGs can also apply to the network card or the virtual address of the resources, whether it be virtual machines, web applications, and we'll take a look at this as we go through these recordings, all the different networking pieces that can have a virtual address assigned to them, you can apply an NSG to that specific address. So now, if you had multiple devices or resources within the same subnet, I want to be able to stop them talking to each other. So how do I do that? I can do that at the network card level. And this is also where you get the right-hand side of the slide, a thing called an application security group. Because now you might have a grouping of resources that might span multiple subnets. They might even span multiple VNets. And you want to be able to group them together so that those resources can only talk to each other. And so it's not that it's an either or. NSGs, network security groups, apply at the subnet and the network card level. And they all filter. So you have to have an inbound connection through the network settings. You got to have a network inbound connection at the network card level if it's set up, and export, or in the outbound, you want to have the path open for both of them. Now, after the NSGs are applied, you then also apply the application security groups. So it's a merger of the two of them. So if the NSG stops the traffic, it will never get to the application security group to allow it. Now, if it gets through the NSG, but then the application security group stops it, you're gonna then have that traffic stop. So make sure you got that order of operations properly configured, because I've seen environments before where somebody will come in, oh, I just learned about application security groups. They'll throw them over top of it and they're going, wow, it's not filtering it. Why isn't traffic getting through? Because the network security group is stopping it from getting into that environment. Or maybe people thought it was working before because they configured the network security group to allow the traffic, and they're going, how come my application is not working? Because maybe someone's dropped an application security group in afterwards, which is now blocking that traffic. So again, the management tool, as well as the Microsoft Cloud Security Benchmark and Windows Defender for Cloud, are great ways to manage those configurations to make sure we don't get those conflicts. So the UDRs, that user-defined route, as we talked about, is a way for you to customize. It's not really a security boundary, but it's a way to shape the traffic from an optimization perspective. It's a great way. It's a great way. It's a good suggestion to use. But as I said, from a security perspective, is it really a security boundary? Probably not. So we want to take a look at, and I'll draw over this example in just a second, but here's an example of planning your virtual networking. So having virtual networks have subnets, but then I needed to have maybe multiple VNets that I'm working with. We mentioned that VNets were a regionally based resource. Absolutely. You can have VNets, two VNets in the same region. So maybe they need to talk to each other. Maybe there are two different applications that need to talk to each other. The diagram here is showing what's called a hub and spoke environment. So maybe you have a central entry point that you're going to have a whole bunch of resources to manage infiltration or internal or access to the resources. And then from there, you're going to farm it off to possibly other VNets or other VNets in other regions for them to communicate. So I just want to talk about some of these for a minute, and then we're going to show you how you can now set up communications between all of them and some of the security features. So let's go into just a whiteboard. I'm going to draw on the slide itself, and we'll highlight a couple of these pieces along the way. So we've got our three VNets that have an address space. Inside of these VNets, we then get subnets that get a range of addresses that's associated with this subnet range of the VNet itself. And so this subnet range might be, let's say, 10.3.1.0/24. This one might be 10.3.2.0/24. And this one might be 10.3.3.0/24, just as an example. So there's three subnets within a VNet. Now, for whatever reason, I've got some resources in the top left and the top right that need to gain access either to or from this hub network that we've created. And you can see that we've got just a single subnet in there, and they've got their addresses that they're working with. Now what I can do is using a feature called VNet peering, because we used to do this in the past, that we would have to create a VPN gateway between all of these communications. Now, I will have a VPN gateway in here, but we're going to cover that in another part of the recording, so I'm not going to cover it right now. But as opposed to having to go through the manual configuration of creating VPN gateways in both of the subnets and managing all the resources and the cost that comes along with this and the security, we have a feature called VNet peering. We're using the backbone of Azure, and that's the security feature I want to point out. So this is using private communications in the Microsoft private network to take all the communications from the 10.3 network and privately communicate that using secure VNetting to access the other VNets that we're working with. Now, this is not encrypted traffic. I want to stress that. So if you need encrypted traffic, VNet peering is not going to be the solution for you. But by default, this does a whole bunch of work for you. It creates, in the back end, you don't get to see it, it creates a gateway network. It creates default gateway features and allows these two VNets to communicate with each other. Now, by default, all the subnets talk to each other, as well as all the subnets in a VNet talk to all the subnets in the other VNet. So all those is where you might want to start taking a look at changing that with either UDRs or even using security boundaries using the NSGs, the network security groups, at the subnets to stop that communication. Okay, so what I want to now do is bring all these ideas together and show you how they might fit into an overall solution. So inside of Azure, now I've drawn it as a building, but we're going to consider that this is a VNet. So that's my VNet. Inside of my VNet, I get subnets. So I've got 3 subnets on a 10.1 network /16. I've broken this into 3 subnets, 10.1.1, 10.1.2, and 10.1.3. Now remember, the system-defined routes automatically have all of these subnets being able to talk to each other. That's the default. Now I can apply a UDR, or user-defined route, that either merges with or overrides the routings that are defined by the system-defined routes, and I could now have preferred traffic methods, but it's not a security boundary that we have. So what I can now do is at the subnet level, I'm just going to erase all of this, I can put an NSG at each of the subnets within the VNet. And I can say I allow inbound traffic from anything, and I allow outbound traffic only from my subnet, or some of it, and I allow inbound traffic from the front end. I'm going to call this the front end, the middle tier, and my back end. I allow only outbound from the middle tier and from the to the back end, and I'll allow my back end to talk to the middle tier. So that way, I have no way of making a compromised front end being able to get to the back end or my data tier. So my NSGs are a great way to do that, and that's free. Now, what I want to be able to do is to have 2 VNets talk to each other. And so here again, I'm now going to include another VNet at the 10.2 network, and it's done a similar thing with subnets inside of each one of them. Now, what I don't have to do by using VNet peering, what a VNet peer is going to do is it does all of this heavy lifting for me. It builds the gateway devices, it creates the connections to each of the subnets, it builds the gateway network, and allows those 2 VNets to talk to each other. And here again, this is where I want to use my NSGs to secure the communication from one VNet to another. Maybe I want these 2 front ends to talk to each other, but I don't want them to talk to the middle tier. So all of this at scale becomes a bit of a challenge to manage. And that's where the Microsoft Cloud Security Benchmark is going to allow you to manage and make sure that these configurations are working properly. Now, if I just back this up a bit, now let's not say that this is Azure to Azure. We're going to come from your on-premises network. So I want to be able to communicate from my on-premises network to Azure. So I'm going to need a public IP address and some VPN device. I'm going to need a public IP address and a VPN. Now that VPN has to exist inside of a subnet. Now it could be part of the existing one that VNet that I've got, so 10.1.4.0/24. Remember, it's all part of the same subnet, so it automatically is going to be able to talk to all of these. It could even go to another VNet in VNet peering. And now I can set up a communication with a gateway device. Now, by default, this is going to be an encrypted traffic. If I wanted to create what's called a secure public VPN, I could put a firewall inside of that subnet to provide that deeper level of packet inspection of the inbound traffic. So if you ever hear the term about a secure VPN, the secure VPN by itself is encrypted, but if you needed to do a deeper level of inspection of the traffic coming through the VPN, you could add a firewall to that component. So there's a look briefly at how all these pieces could fit together from a communication part. So let's go back to the class. So just pointing out a couple of the features there. So VNet to VNet communication can be made secure to a degree by not putting it across public communication environments. It's using the backbone of Azure by using VNet peering. Now, there's two terms that we use. VNet peering specifically relates to in-region communication from one VNet to another. We have global VNet peering that allows your VNets to talk to each other literally across the globe using the Microsoft backbone. But the key, non-encrypted traffic. And we'll talk in a later part of the recordings where we're going to take away, if you need that encrypted traffic, you could create a VPN gateway to create that communication and have that traffic encrypted. Now, taking a look at the traditional way, and this is going to be done, we're going to start off with public to private communications. So you're now taking, your on-premises network, that's what you're seeing on the right-hand side of the slide, and you're probably doing this right now. Maybe you've got a data center that you're working with and you've got a series of remote offices, and you've probably created a VPN network that takes those remote offices and connects them to the data center. We're doing that same concept now communicating to Azure itself. So much like I showed you in that last slide, we saw that in that hub network, we had a VPN gateway and we had a VPN subnet in that hub network that we were dealing with. And so that becomes the entry point. And because of VNet peering, I could now VPN to the hub network, and because of the VNet peering features, that communication to the hub network allows you to get to all of its spokes that you're dealing with. And so in this model, you're seeing in a traditional manner, you can see in the middle that they've got a VPN tunnel there using the encryption protocols from on-premises to that virtual hub network that you've created with the VPN device. Now, we can configure this several different ways. You can go site to site. So in this diagram, we're taking a site location from your on-premises and we're marrying it with a VNet inside of Azure. Hopefully it is in that hub and spoke model that you're dealing with, because you don't want to have to create a VPN connection to each component of the application. So in that hub and spoke, if you had those three subnets, I don't need to create it to all three because that gets one, difficult to manage, and also gets twice as expensive as it needed to be by just coming to a hub network. So we can go site to site. Now all the resources in your on-premises network can talk to all the resources inside of the VNet and its hub and spoke network it's dealing with. And again, why you might want to use NSGs to stop the traffic. Maybe you want internally in Azure those resources to talk to each other, but I don't want people from the VNet network from communicating to all those resources. So again, NSGs are going to be a great way to implement that. Now, I think that there's a better diagram that's going to show this. In this site, you have a site-to-site VPN. Now, the gateway service that you're seeing here, that comes from what's called a SKU or a stock keeping unit. They come in various sizes and capabilities. So if you take a look and go look at the documentation for VPN SKUs, you'll see that there's a whole range of number of connections of site to site and point to site, and some of them have as little as 30 connections that can have. We're showing 2 from 2 different remote offices connecting to the same VPN gateway. Absolutely, as long as you don't exceed the capacity of the number of connections. The other thing that you want to be careful of is the VPN gateway device, not only the number of connections, it has a limited throttled bandwidth. So maybe it has 1 gigabit, maybe it's got 650 megabits, maybe it's got 5 gigabits. It is shared traffic with no QoS across all the connections to that gateway. Now, it can form and work in what's called an active-active or an active-passive environment. And so by default, it has 2 potential IP addresses that you can communicate with. If it's active passive, it provides fault tolerance and redundancy if the SKU provides that feature. And that way, if you lose the VPN gateway in Azure, it provides fault tolerance as well as some security capabilities that now you can fault tolerant and fail over to another VPN gateway as the passive address becomes active and all the communication starts over there. Now, it will cause a small interruption as it switches from that one IP address to the next, but we have that capability. Now, you can configure redundant connections, again, from a security and or high availability perspective. If you were to draw that same diagram, you can go from an on-premises location and actually create a VPN connection to both the IP addresses in Azure, or you can have a fully meshed environment. I could have 2 VPN gateways on premises. I've got the 2 addresses on my VPN gateway inside of Azure, and I can now have them be active to each other with a passive falling over to the other one. So provides this high availability, and then you have security over top of that you could take a look at. So all of these are possibilities to meet your high availability and security need. Now, the other one that we have is a point-to-site communication. These VPN gateways, as I said, have a variety of throughputs, number of connections that is site-to-site, and number of connections that are available on a point-to-site. And so these are individual locations, exact same technology connecting to the VPN gateway itself, allowing them access to that VNet and any of its VNet peering configurations that you've set up. Now, I mentioned at the very start of this VNet peering. And when we have that VNet peering, it actually took the place of this, which we used to have to do in the early days of Azure. And so I would actually have to create a public IP address in that VNet, say the one that's on the left-hand side there. I would have to come out through a VPN gateway and connect to another region or even another VNet in the same region to have them communicate with each other. That's why Microsoft implemented VNet peering. Took away all of that complexity and need, but it was not encrypted traffic. If I need to implement encrypted traffic from my VNet communications inside of Azure, the only way you're going to be able to do that is to use this VNet connection, and you would have to create a VPN gateway in those 2 VNets and connect them, and then you're going to get the tunneling protocol and the encryption that comes along with that. Now, we're providing new advances to this all the way along, adding new features, but right now this is the way that this is set up, that you can now have encrypted traffic between your VNets, but you have to go through the complexity of managing and implementing a VNet gateway between those 2 VNets. We provide a wide variety of different encryptions across Azure, and we're going to be taking a look at them granularly when we take a look at storage encryption, database encryption, and communications. Now, wherever possible, we talked about the internal communications inside of Azure, say, for example, for VNet peering. That is non-encrypted, but it's secure traffic. Your security, because you might be on the same physical, fiber optic network as somebody else, but those subnets and that communication between your networking and some other customer in Azure's networking is secure from each other, but it's not encrypted traffic that you're dealing with. We have a wide variety of encryptions we've talked about. If you want that, you can get it available for you. That provides both server-side and client-side encryptions that you need to implement. You can see down at the bottom. So in transit, you can use TLS, or the transport layer security. We provide for not just TCP protocols. Some of the communications can be configured to use SMB, or the server message block. For example, access to Azure file shares is using the SMB protocol over TCP/IP, and that's where you're going to get your encryption. Our VPNs, as we just showed you, have encryption, as well as through the HTTPS protocols as opposed to HTTP. So there's lots of different ways to implement at the network level, different types of encryption if it's needed. Now, as much as I talked about at the virtual network level, that within a VNet, you have subnets. All the traffic within that subnet can actually see each other. So it's, just like you would in your classic routed environment. If you have a network segment all the communication in that network segment can be seen by all of the other devices in that network segment. Well, we could go in and use an application security group, maybe to configure a grouping of servers or devices that meet an application that communication is going to have an NSG that stops it from seeing traffic from the other one. That's one way to stop that. But we also have the capability in that first bullet point, when you're building things like VMs, scale sets, and VM availability sets, we can now have a feature where there is encryption between those devices called DTLS that will now allow for encryption between those devices on the same network segment that they're working with. So they're adding these features to provide that encryption over top of just using NSG. So not only is it secure from seeing other devices, but the actual traffic itself is going to be encrypted. We also are going to see that as we go into applications, and we're going to look at AKS or Azure Kubernetes services, ways to be able to encrypt the traffic between your nodes and pools of servers and possibly even the pods that you're working with to provide for that encryption to happen for you. Another form of network communication beyond the VPN environments that we have is a feature called ExpressRoute. Now, these are dedicated third-party communication protocols that allows you to call up a network provider. So you're going to call up one in your region. I think there's, at last count, 31 globally. So you call up a major telco, and they have a thing called a POP, or point of presence. And so looking at that diagram, on the far left-hand side, there's your network, and you call up this network provider, and they will take a dedicated communication line from your location to their point of presence to their thing called an MPLS network. And so the MPLS network provides high routed traffic and guaranteed delivery through their MPLS network to the other end. And so that they can connect to point of presence for Azure. Some even actually connect directly to Azure's themselves, and they can provide 5 gigabit, 10 gigabit, up to 100 gigabit traffic. And so now, instead of having to have all these VPNs that you create between your on-premises environment and inside of Azure, you can connect your entire office and have the entire office go out through this express route, go through the MPLS network, and now it's not just secure traffic, because it's now segmented just like we do internally to Azure. So other customers that might be on their MPLS network are not going to see your traffic, but you can have ways to set up VPN connections and actually have that traffic being encrypted. Now you're seeing in the diagram in that middle part, that's the magic, that layer 2, layer 3 transport management and delivery of the traffic through the MPLS network. Now you're seeing two sets of traffic on the far right-hand side. Now this was designed for offices that maybe have people have the M365. That's the Microsoft cloud offering of our Office suite. So you can actually have a dedicated communication that goes through, it's called the Microsoft routed network, that's going to route it to our M365 applications. Or you're seeing at the bottom there, that's your secondary channel that's going to be able to now have you make those VPN connections and those type of network connections to your Azure resources. So whether it be VNets that you're dealing with, and we'll take a look at other networking resources that you can communicate with. But an express route, and there's a big model that talks about all the different types of express route. You can have virtual WANs with global routing in here. So I'm not going to get into all of it, but that is one way to make that network connection. So looking at that specific encryption, you can now see that I can use that express route, that's that middle piece, from your on-premises location. I could now use, instead of having to have public IP addresses at both places or endpoints of the VPN gateway, you don't have to have a public IP address on your side. You don't have to have a public IP address on the Azure side, but you can still create that VPN connection through the express route. I mentioned earlier on in the recording about NSGs, or the network security groups, as that free 5-tuple hash inbound, outbound monitoring of traffic. Now, I use the analogy, it's like a bouncer. It doesn't know anything about the people. It asks you for some identification. If you can prove that you're who you are and you're on the list or whatever to get in, you get in. So it's just this kind of brute force allowing traffic in or out of an entry point. So that's what the NSG does on that 5-tuple hash based on IP addresses, port and source destinations, all of these different features. Now, a firewall is a much more expensive I guess much more is always relative, but it is a device that you have to pay for, so that's much more than free. But it's a device you have to pay for, but you get more capabilities. You're going to get things like SSL offloading. You're going to get features like deep packet inspection. Again, I'm not here to teach about all those features, but from a security perspective, if you need those features other than just pure inbound, outbound packet filtering and where you're coming from, where you're going to, those kind of features, if that's all you care about, NSGs are perfect. And I would not use one or the other. We use them in concert. So where I use typically firewalls is in that public-private ingress-egress. Anytime that I make that transition from public access information to my private information, I would like to do something more than just say, where's it coming from, where's it going to, what kind of protocols are you working with? I need to actually take a look at what's inside of those packages. Maybe I want to decrypt the information if it's come in and encrypted. So think about firewalls as being something you should use in that public-private, as well as then implement NSGs inside of your networking environment to make sure that the internal communications are going to be secure. Now, you'll see on the top part of the slide, there's two options that you have available to you. There's the Azure firewall. Now, the Azure firewall, it's built by Microsoft. It's built on industry standards. I'm not going to get into the whole infrastructure, but it's a fairly simple process. You just ask for an Azure firewall. The nice thing about it is it scales. It scales up and down to meet your requirements without having to go through a whole configuration. Now, on the right-hand side of that slide, if you have currently on premises, maybe a third-party solution, maybe you're working with Fortinet or you're working with Cisco or any one of the other F5 devices that are out there, Microsoft inside of Azure offers all of those products. Now, from a security perspective, if you already have a security management of all your own firewall devices, you may want to extend to Azure and use those same devices inside of Azure, and that way you're going to be able to implement your management security policies that match your on-premises world. You can then measure them through the Microsoft Cloud Security Benchmark using Defender for Cloud to make sure that it's not just the same in Azure, but on-premises. So you do have that option, that top choice. Firewalls are firewalls. They provide a deeper level of security and encryption or inspection than you're going to get from an NSG, but you have both those options available to you. One of the tools that's available to you is Network Watcher as a feature to manage your network. Because remember, unlike if you're familiar with Wireshark and some of these other tools that you might have used where you manage the physical network, you can actually get onto that network to see the communication. Inside of Azure, you're not going to have access to the physical wire, but to give you access to the same kind of information, it's going to be amongst, remember, that big fiber optic cable that we have all of Azure's traffic working through. We've got yours secured from other people's traffic. That's great. But to be able to get that look inside of your network environment, Network Watcher is the tool to do that same kind of thing that you've done in the past. So you're seeing on the right-hand part of that slide, all of those kind of monitoring tools that you would have used things like Wireshark for, to do your security inspection, to do your analysis, those tools are going to be made available through Network Watcher for you to be able to get that level of detail and inspection. So what we've now taken a look at is some of the fundamental networking components that are available to you and how they relate to a security component and how you can implement them or include them in your MCSB and your Windows Defender for Cloud assessment to implement, monitor, and secure your network environments. I look forward to seeing you in another recording.